We'll begin with similar fractions. 1/3 and 2/6 and 20/60 all have the same value, yet they look different, don't they? That's why they're called similar fractions. Okay, because basically they're the same thing, they just look a bit different. So, how do you check if a fraction is similar, besides it just being obvious, like in this case, you know, you times the top by 3 and you get the bottom bit, times the top by 3 and you get the bottom bit. That's one way of sort of checking that you've got the same fraction, isn't it? Okay, but another way, a more standard way, is to whatever you do to the top, you should do to the bottom. So I'm going to times the top by 2, or double it. 1 times 2 is 2, so I'm going to double the bottom bit. 3 times 2 is 6. I've got the same fraction, yeah? So this is converted to that. Wherever I did to the top, I did to the bottom. I can do 1 times 20 gives 20, 3 times 20 is 60, therefore 1/3 and 20/60 are the same fraction. And basically I can either times or divide. Yeah, so I can times to make it bigger, or I can basically, another way of talking about dividing is cancelling. So if I cancel a big fraction down, it will turn into a similar or equal fraction. So divide top and bottom by 10, for example, will give me 2/6. So divide top and bottom of 20/60 gives me 2/6. Divide top and bottom by 2 gives me 1/3. So that's that. Reciprocal fractions, what are they? Basically it's one fraction turned upside down to give the other fraction. So the arrow is going both ways, because if I turn this fraction upside down, I get back to that, obviously. Now, how do you do the reciprocal of a whole number? Because it doesn't look like a fraction, does it? Well, maybe I should have had this one before this one. The idea is that 4 can be turned into 4/1. Any whole number can be turned into a fraction by dividing by 1, because dividing by 1 does nothing. And you might be saying, where do I talk about divide by 1? Where does it say divide? There's no divide sign. Well, actually, a fraction sign is actually a divide sign. It's just another way of saying divide. So 4 is the same as 4/1. And if you flip 4/1 upside down, you get 1/4. So that's the reciprocal of that, and that's the reciprocal of that. So, as I just said, any whole number can be put over 1, because over 1 dividing by 1 does nothing, so in reality it's the same as that. So that's that. Let's get to the next thing. Okay, so we're finally adding fractions. We're actually doing something with the fractions. A quarter plus 2/4 is 3/4. That makes sense. 1/4, there's another 2/4. How many quarters have we got altogether? We have 3/4. Very easy. Very easy, because the bottom bit of the fraction is the same. When that's the same, that makes it really easy. The bottom bit is called the denominator, the top bit of the fraction is called the numerator. So here's a question where the denominator is not the same. So let's sort that out. Let's make the denominator the same so we can easily add the fractions. Well, as we're talking about over here, there are things called similar fractions. So we need a similar fraction which has the denominator being 8. So to get to 8 from 4, I have to double it, times by 2 gives you 8. Notice I don't add or take away to make similar fractions. I didn't mention that. You have to either times or divide. Maybe I did mention that. Anyway, so times top and bottom by 2, you get 2/8. And so 1 times 2 is 2, 4 times 2 is 8. And now I've got an easily addable fraction. Okay, because you've got 1/8 there, you've got 2/8 there. 1/8 plus 2/8 is 3/8. Very simple to do. So I changed this slightly complicated question into this very easy question. So the answer, 3/8, is the answer to 1/8 plus 1/4. Now, very similar sort of situation to this, 1/6 plus 1/8. This time I can't double double or triple this to become a number like that, or vice versa. Can't take the 8 and make it into a 6, so I have to times both of them by something that they both go into. What are they both going to? They're going to 24. So 6 times 4 is 24, so I have to do 1 times 4 is 4. 8 times 3 is 24, so I have to do 1 times 3, which is 3. So now I've got a very easy thing to do. 4 over 24 plus 3 over 24 is just 7 out of 24. Let's move on to the next one. So now we're going to add again, this time with... So let me say that again. So now we're going to add again, this time with whole numbers. So 2 plus 3 is 5, and a quarter plus 2 quarters is 3 quarters, and that's done. Very simple, isn't it, really? Sometimes 1 quarter, this fraction and this fraction makes more than a whole number, so you stick it onto that. On top of the 5, I would have added whatever extra stuff came out of that. But anyway, that's the idea. Let's do a bit of taking away. There aren't too many examples of taking away because it's basically the same as adding. Make sure the denominator is the same. That's the idea. So 3 quarters take away 2 quarters is 1 quarter. You got 3 over there. Take away 2 of them. You've only got 1 quarter left. Simple as that. 1 take away a quarter. Well, 1 is in fact 4 quarters, right? That's one way of looking at it. And the reason why I'm talking about quarters is because that's already quarters. So I'd look at 1 as in terms of quarters, which is 4 out of 4, which is 4 quarters. So 4 quarters take away 1 quarter will leave you with 3 quarters. Simple as that. Timesing is very easy. Times the tops together to get that top answer, and times the bottoms together, denominators together to get the denominator of the answer. So 2 times 5 is 10, 3 times 7 is 21, and we're done. Before I go to question 12, I'm going to do question 13 because that helps with that. How do you convert a mixed number into a fraction? Okay, what do you do? Well, you look at 3 in terms of fifths. Okay, now to keep it really simple, I'm going to look at 3 as in 3 whole numbers. Earlier on, I said that 1 was 4 quarters, right? If I wanted to talk about it in terms of quarters. So 3 is 3 whole numbers. I could say 3 is 1 plus 1 plus 1. Okay, and 1 can be written as 5 quarters, couldn't it? If we're talking about fifths, 5 fifths. So 5 fifths, another 5 fifths, another 5 fifths. We've got 3 times 5 fifths, okay, which is 15 fifths, and then we've still got that 1 fifth from at the end over there, which is that 1 fifth. So you've got 15 fifths here, and 1 fifth there. You've got 16 fifths. So it sounds quite a long thing to do. All you really have to do is say 3 times 5, okay, because, well, you can say we're going to have 5 fifths 3 times. So 3 times 5 makes sense. 3 times 5 is 15, plus the 1 fifth that's here already gives you 16 fifteenths. Okay, now 2 times 3 fifths is obviously 6 fifths because we've got 3 fifths twice. 3 fifths and another 3 fifths gives you 6 fifths. So that's very simple. Just do 2 times 3, which is 6, and you've got the 5 carrying on there. Or if you really want to, you can think about it like this. 2 is in fact 2 over 1. So 2 over 1 is times 3 over 5 is 2 times 3 is 6. 1 times 5 is 5. Done. What about division? Division is very simple because it just turns into multiplication. All you do is you take your division and you say turn the divide into a times, and take your second fraction and flip it upside down. So 5 over 7 becomes 7 over 5, and then times them together, and that will give you your answer to the original question. So this has the same value as this, which is simply this. 2 times 7 is 14, 3 times 5 is 15, and when we've got mixed numbers, Oh, I forgot to go back to this one. When you're timesing whole numbers, sorry, mixed numbers, you have to convert them into normal fractions. The reason is because when you times, you simply times the tops of the fractions together and the bottoms of the fractions together. We don't have tops of fractions here, except for bits of the original question. But what about the 3's and the 2's? You can't just do 3 times 2, because that's not how timesing works. Timesing works in fractions when you times the numerators together and the denominators together. So we need a single numerator here and a single numerator there. So as I said, we have to turn it into a fraction. In fact, it's going to be a top heavy fraction, so the top part of the fraction is heavier or bigger than the bottom bit of the fraction. And as we said earlier on, you just do 3 times 5 plus 1, which is 16/5, and this one is 2 times 4, which is 8, plus 3 is 11 quarters. So 4 stays on the bottom, 5 stays on the bottom. So now we've got this, and we're going to do a bit of cancelling as well. So that's another thing to bear in mind. When you've got timesing going on, okay, you can cancel between the fractions diagonally or normally, like we said here. So whatever you do if you divide top and bottom by the same number, you can cancel like that, or you can cancel diagonally. But this number, 16/5, there's no number that goes into 16 and 5, so you can't cancel vertically, so you can cancel diagonally if you want to, if it's possible. 16 and 4 both divide by 4, so 16 divided by 4 is 4, 4 divided by 4 is 1, so it simplifies to that, and I just simply time them across. 4 times 11 is 44, 5 times 1 is 5. Okay, so as I was about to say, if you've got division, it turns into multiplication, and because it turns into multiplication, I need to change it into, you know, simple fractions. Okay, and as we worked out earlier on, 3 and 1/5 is 16/5, so you got the 16/5 there, and 2 and 3/4 is 11/4, but because I'm doing a division, I'm going to take the division and turn it into a times, and turn this 11/4, which is over here, which is the same as that, into 4/11, and then times them together, and we get 64/55. And finally, 3/10 of 15 means 3/10 times 15. Okay, because when you times, you get that much of the 15th. So anyway, 3/10 times 15th, 10 and the 15 cancel together, both divide by 5, 15 divided by 5 is 3, 10 divided by 5 is 2, so now you get 3 times 3 is 9, and 2 times the hidden 1 underneath, which is 2. And that is it.